If you work in a CSSD, you're certainly no stranger to biological indicators. And if you happen to look at their instructions or some related literature standards, you've probably frequently come across a very important related concept, the d-value, usually expressed in minutes. But what does this d-value actually mean? The behavior of microorganisms in a sterilization environment is quite unique. When we try to kill germs, a common and likely assumption is that a fixed number of microorganisms are killed over fixed time intervals. In other words, if, say, 1,000 are killed in the first minute, then another 1,000 should be killed in the second minute, and the same for the third. However, laboratory measurements showed that the kinetics of microorganism killing don't work like that at all. Let's take an example. Suppose we have a sterilizer that can immediately begin a 121 degrees steam sterilization process. Now we place 1 million spores inside, close the door and start the cycle. After, say, 2 minutes, we immediately stop the process and count the remaining spores. We find that only 100,000 spores are left. That means in 2 minutes at 121 degrees, 900,000 spores were killed. That seems like great news, right? We killed 900,000 in just 2 minutes and only 100,000 remain. Theoretically, if we continue the sterilization, the rest 100,000 should be wiped out in just over 10 or more seconds. But if we actually continue the experiment, put this 100,000 spores back in, sterilize for another 2 minutes, and stop it and count again, we won't find 0 spores. Instead, the number drops to 10,000. We could keep repeating this, keep sterilize. Every 2 minutes we count. The number would fall from 10,000 to 1,000, and then to 100, and then 10, and finally to 1. So what does this example prove? It shows that in a sterilization environment, microorganisms will be killed according to a fixed rule, that is, over a fixed period of time. 90% are killed, or only 10% will survive. This is not a rule we invented, it is a pattern reproducible in any laboratories on Earth. So what exactly is the d-value that we often refer to? A fixed period of time was needed to reduce the population to 1/10 of its previous number. That fixed time period is what we call the d-value. In general, the d-value represents a microorganism's resistance against sterilization. A higher d-value means it takes longer to kill the 90% of the population. If it takes longer in the same sterilization environment, it is harder to be killed. Conversely, a lower d-value means it takes less time, so the microorganisms is easier to be killed. One important note here, unless otherwise specified, the d-value in a steam sterilization condition is assumed to be at 121 degrees. Why emphasize temperature here? Because increasing the temperature speeds up the sterilization rate. That means the time required to kill the spores will be shortened, and therefore the d-value will be smaller. If we want to calculate the d-value at a different temperature, say 134 degrees, we will need a specific formula. That formula is not overly complex, but it involves the concept of the z-value, which we will explain in a future video. For now, just remember that a d-value is typically given for 121 degrees. For spores, Bacillus stereothermophilus, the common d-value ranges from 1.5 to 2.5 minutes. In our earlier example, we used 2 minutes. As a summary, d-value represents the resistance of a microorganism against sterilization condition. It is a fixed time interval when population of microorganism drop to its 10%.